remains.
Welcome students. Today we have to learn the usage of dimensional analysis. Basically here we use the dimensional analysis for three purposes. First purpose is to find out the correctness of a physical equation. Right? So this is the first use. Second one, to find out the conversion factor of a unit of the same physical quantity in two different systems of unit. And third one is to find out the relationship between the different physical quantity, or to establish the relationship between the different physical quantity in a given formula. Right? Now this will be the three uses. In that we want to see the first one. Which one? To find out the correctness of a given equation. It means that here we want to prove that the dimension of a LHS side and the dimension of the RHS side is same. Right? So you want to find out that. So for that, here we want to take the one of the example. Here we know the three kinematical equations. In that we take the second kinematical equation, and we want to find out the correctness of that kinematical equation. So here first one, that is first use is to check the correctness of given equation. Right? So for that, here the example is, here we want to use the second kinematical equation. So the second kinematical equation is displacement, which is equal to the, what to get there, ut plus half of at square. Here s is the displacement, here t is the time, here u represents the initial velocity, then half is simply number, then here a is the acceleration, and again there t is the time. But again we know that the dimension of all these quantities, what to get there, here the dimension of the displacement is, what to get there, dimension of displacement is simply L1. Displacement is nothing but the length, so that's why their dimension is simply L1. Then the dimension of the time is, what to get there, dimension of the time is simply T1. Then initial velocity is nothing but the simply velocity, so that's why what to get there, here the dimension of the velocity is, what to get there, simply L1 and T minus 1. And now this will be the acceleration. Here the dimension of acceleration is, what to get there, change in velocity with respect to time. So as per that, here dimension is L1 t raised to minus 2, that is L1 t minus 2. So this will be the dimension of the acceleration. Now we want to substitute this dimension here. So what to get there? Here dimension of S, which is equal to the dimension of U into the dimension of T, plus here this will be the half. So avoid that. It is simply number, right? Because of this will be the dimensionless quantity. So that's why avoid that. So here we want to take the simply A, that is acceleration. And now this will be the T and their square. Now we want to substitute these dimensions in this one. What to get there? First of here, dimension of S is L1. Right? It means that here we write here M0 L1, again here T0. So this is the dimension of the displacement. Similarly, dimension of velocity is simply L1 T minus 1. Right? And again here time is simply T1. Plus acceleration is, what we get there? Acceleration is L1 then T minus 2. And again here time is there simply T1 and again there bracket square. Then again we want to simplify this one. So for that here we want to keep this LHS side is as it is, that is M0 L1 T0. Right here again here we want to take the we want to use the law of indices. Here this is the multiplication. And we know that in multiplication, if the base is same, then there we want to add their powers, right? So that's why here. First of here, in this one, mass is not present, so that's why their dimension is 0. Then L1 is as it is. Then here, what we get there? T minus 1, again there plus 1. Here we use the law of indices. Similarly for this one, what we get there? Here, this L1 is as it is. Again here, this T raised to minus 2, which is also as it is. But here, what we get there? T1 raised to 2. Just like here, A raised to M raised to the N. So what we get there? A raised to Mn. It means that we want to take the product of their powers. That is Mn. 1 into the 2 is simply 2. And now again here, base is same. So that's why here, we want to add their powers. So that's why here the power of first one is minus 2 and second one is there simply plus 2. Right? Then now again here we want to simplify this one. Again here this LHS side is as it is M0 L1 T0, which is equal to the, right? So here what we get there? This M0 is as it is, L1 is as it is. Then what we get there? Here the power of T is minus 1 plus 1. What we get there? Minus 1 plus 1 is nothing but the 0. So here we get the 0. Similarly, in this case, what we get there? Here, the power of M is 0 because of their mass is not present. Then this L1, which is also as it is. Then here, minus 2 plus 2. What we get there? Minus 2 plus 2 is nothing but the 0. It means that the power of time, which is also 0. Right? And again, we know the general rule. We add only same quantity. It means that we add length with length. We add mass and mass. We cannot be add the length and mass. So that's why here, what we get there? This will be the length. Again, this will be the length. Right? So with the addition of these two lengths. So what we get that length plus length is nothing but the length. So that's why here the dimension of this one is, that is RHS side is simply M0 L1 T0. Now here we get the two terms and the dimension of both the terms are there same. So that's why instead of these two times simply we write down these dimensions only one time. Right? So this will be the RHS side. Here what we get there? LHS side is M0 L1 T0. So here, the dimension of LHS side and RHS side is same. M0, M0, L1, L1, T0, T0. It means that here, the dimension of LHS side, which is equal to the dimension of RHS side. Right? Here, the dimension of LHS and RHS side is same. So that's why the given equation is dimensionally correct. Right? So in this way, we check the correctness of a given equation. Right? See all the equations once.